functions that execute a bunch of code are very well and good, but often we want to get a value back from a function. In this lesson, we're going to talk about how functions return a value and get a result back. Returning a particular value is actually why we often call a function in the first place. The reason we're calling the readCSV function here is because we want to pass a CSV file and get our data as an output and store that data in a variable. Let's look at the mechanics of returning values more closely in our getMilk example. In this case, we're supplying an amount of money as an input, and we're using our input to make a calculation. This part is the same as before. We're dividing the amount of money by the price of milk to calculate the liters of milk to buy. So the question is, how do we return the result of this calculation? And the answer is that we use a keyword, the return keyword, followed by the value of what we want to return. We write return liters. That word, return, is actually a Python keyword. When Python hits this line of code where it says return, it will exit the function and it will return whatever result comes after that keyword. So in our example here, getMilk is outputting the value inside liters. The call to getMilk is actually the same as before. We have the function name and the value for an argument, say 20.5. However, if we run our Python code just like this, our output is lost. Our getMilk function is returning a value, but we're not storing this value anywhere. So what you'll typically find is that when a value is returned by a function, we're going to be storing that value in a variable. In this case, our variable called amount is now holding on to 20.5 divided by 1.15, or around 17.8. But so much for the theory. Let's put this into practice. Suppose you're working for a cutting-edge Silicon Valley company, and you're building a calculator. You are the engineering lead on the team, and you have been assigned the incredibly important task of programming the multiplication button. As a challenge, can you do the following? In the Jupyter Notebook, create a function called times, and have this function take two inputs. It needs to multiply these two inputs together and provide the result as an output of the function. Also, you need to test this function that it works. So call your function and multiply 3.14 and 5.09. Store this value in a variable called, test, and print out the value of test below the cell. I'll give you a few seconds to pause the video. You ready? Here's the solution. The first thing we're going to do is define our function. So we're going to use the keyword def. We're going to give our function a name and call it times. Now we're going to provide the two parameters, say x and y. You can call these parameters anything you want to, by the way. We then have the colon, hit enter, and say we want to store the result of the multiplication in a variable. So we'll say result equals x times y. And then to output the value of this function, we'll go with return result. Notice how return is colored in green because it's a Python keyword. Now suppose you called your parameters a and b instead of x and y. Then you got to be consistent. You got to have a and b inside the body of the function as well. So now that I'm done with my function, I'm going to hit Shift Enter, and I'm ready to test it. So I'm going to call times 3.14, comma 5.09, and hit Shift Enter. Our function is working as expected. Now we said we'd store the value of the output in a variable. So let's say test is equal to the times function. And then we can print out test. If I hit Shift Enter now, we see the value of our test variable printed below the cell. Now we can actually simplify the code inside our times function a little bit. In fact, we don't need this extra line of code right here. So I can comment it out with a hashtag, and instead of returning result, I can return the calculation directly. I can say A times B. If I hit Shift Enter on this cell and then hit Shift Enter again on the cell below, I can see that my function is working. My output is unchanged. If you've decided to write your function just like this, then you're doing the calculation on the same line as the return keyword. And this is absolutely fine. Okay, excellent. So let's continue our little story of working at the Silicon Valley tech company and connect this lesson with our previous lesson on data types. Now that you've written your function, you've probably submitted your calculator code by now to the project team, and a few moments later, your boss, an accomplished Python programmer, will walk over and say, "Hey, I've looked at your code and I've got a question for you. Have you watched the Monty Python movie for the Quest for the Holy Grail?" He then pushes you aside from your keyboard and types in times, parentheses, single quotes, NI, single quote, comma, 4. And after typing this code into your Jupyter notebook, he smiles and walks away. Let's see what happens when we run this code. If I hit Shift Enter, I see the word ni displayed 4 times below our cell. Now this is unexpected, right? The times function does something completely different now. That multiplication symbol is not multiplying when we're passing in a string. The multiplication sign, in fact, is repeating a sequence. And what this shows is that the Python code doesn't really care about the specific data types it's running on. In this case, both numbers and strings support this time symbol. Both numbers and strings have some sort of operation that uses this multiplication symbol. Now, what this means in practice is that we, as the developers, when we're writing our Python code, have to run some tests and be aware of the kind of data types that we're working with, and also to detect errors. A reasonable question to ask as well is this a bad thing? And why was our boss not angry when our code did something really weird? And the answer to that question is, Python is really all about flexibility. Ideally, Python code should not really care about the types. And this is in contrast to other programming languages like C++ or Java. Python is meant to be flexible. This is a core part of the Python philosophy, in fact. Returning to our topic of functions, this is a good time to review and summarize the 3 flavors of functions that we've encountered so far. We've seen functions with no inputs and no outputs. We've seen functions with inputs. And we've seen functions with both outputs and inputs. When defining a function, you always have to use that def keyword. Then you have the name of the function, followed by the parentheses, and then the semicolon. Also, very important is that the next line, the one below the header inside the body of the function, is indented. I recommend using 4 spaces. But most text editors will indent this automatically for you. Now, when you have inputs or parameters, they go between the parentheses following the function name. The parameters are like placeholders. They're essentially a variable with a name that gets a value when the function is called. The cool thing about parameters is that you can use a parameter inside the body of the function. And when you have more than one parameter, you separate each parameter with a comma. Finally, we encountered functions that have both inputs and outputs. The key here is that functions with outputs have a return statement. The output is whatever comes after the return keyword. And the way to remember this is that if you're ever dating a programmer and you tell them to go to a supermarket and buy some milk and they never come back, it's because you haven't told them to return anything. So over the past couple of lessons, we've worked quite a bit with different kinds of functions. Before we move on, let's talk a little bit about the big picture for a second. I'm sure that at this point, you're starting to see how functions really help with structuring code. Instead of copy-pasting a bunch of code, we can stick a bunch of instructions into a single function and then just call that one function. That's what's called code reuse. And code reuse basically helps you avoid copy-pasting. Also, because functions can have parameters, we can call them over and over again while supplying different kinds of inputs. So in scikit-learn, we wrote a linear regression that looked at movie budgets and movie revenue. And we can run linear regressions over and over again on different kinds of data. That x and that y in that fit function can have different values, and we can reuse the code that fits our regression model. Again, this is code reuse in action. But there's also a more subtle advantage. Functions allow us to split up complex tasks. And by splitting up a complex task, we get more manageable parts. For example, in this notebook, theoretically, we could have had one function that, parsed all our data and then generated the graph and then did the regression. But we didn't have one line of God code that did everything. Instead, we had different functions that were responsible for different pieces of the workflow. So functions are a design tool for organizing our code. We've actually encountered this idea before with the packages that we looked at. So our pandas package had a bunch of different files that made up the package. Our pandas module did not consist of one enormous .py file. The code instead was split up into a bunch of smaller files. And each of these files had a specific job. So as we're writing our own code, we're going to be battling the same enemies as every other developer out there. We're going to be fighting change and complexity. Change and complexity are the reason why good design and good structure for code is key. And one thing that developers have learned over the past decades is that splitting up a task into smaller, more manageable parts is really important, and it helps a lot. On a small scale, this splitting up of different functionality is accomplished by putting code into functions. And on a bigger scale, this is accomplished by splitting up bits of code into different files. The rationale behind both of these strategies is the same. They're about managing complexity. And on that note, I'm going to leave you with a little Python Easter egg. In your Jupyter notebook, type import this and hit Shift-Enter. You will be greeted by the Zen of Python by Tim Peters. My two favorite lines by a long shot are simple is better than complex, and complex is better than complicated. And on that bombshell, I'll see you in the next lesson.